Hi everyone, and welcome to another part of the Solidity tutorials. In this part we're going to see how we can change the bonding curve integral.sol in a way that the equation that we have for the bonding curve is for the dollar amount instead of the Ethereum amount. So before whatever smart contract that we have written, we would enter the price in the Ethereum amount, and then so it will calculate for us how much we need to pay, and then it would calculate it and give us back the extra amount. And notice that in the previous contract I didn't add this part for subtracting the message.value, the number that you enter as the payer, subtracted by the ETH amount. So you would calculate the ETH amount, but the message.value that you enter might be more than that. So the smart contract needs to pay you back the price that you shouldn't pay, right? So for example, you enter 2,000 Ways, but there's only 1,800 Ways needed to pay in order to buy that token amount. So 200 Ways needs to be paid back to you. So make sure you add this part to your contract in the buy tokens, but the sell tokens, it's alright. So we've got this contract, and notice that in these kinds of contracts here we've separated the functions for much more clean coding, but in the actual world where we want to pay less gas fees on the testnet or mainnet, sometimes it's better to make the functions bigger, have less number of functions for making a process happen. So here when we want to buy the tokens, we use this function, calculate ETH amount function, and integrate functions. So there are three functions, but imagine that we would just unite all of the three functions into one, integrate them all into one, and do the process. However, it's much more clean coding writing it this way, but in that way we will have much less gas fees than this one. So these are the considerations that when we want to deploy this contract on mainnet or testnet, we will change the contract so that the gas fee will be less than we have right now. But here the way I've written it is just for educational purposes, so make sure you customize it in your own way according to your own needs. Anyway, let's get back to our discussion about the ETH price and the dollar price. So imagine that the formula that we have here, A multiplied by supply to the power of 2 plus B, is for the price in dollars. So for example, when we want to calculate the price in dollar, then for a specific number of tokens, so for example you have two tokens, A is 1, B is 100, so the price for the token 1 is 101, for the token 2 is 104, but it's in dollar units, right? Not in the way unit. So previously we learned how to do the price conversion like this, and we wrote the smart contract. So we want to apply this in this contract in a way that instead of the ETH amount, we would first calculate the dollar amount, then convert it into ETH amount, and then we would return the ETH amount. So this is a more straightforward way in order to work in the real world, because in the real world most of the things you want to buy, you ask how much dollar is it, rather than asking how much Ethereum is it, right? So most of us can better understand the prices when it is in the unit of dollar, right? So in that way we can also calculate the price of dollar. So we can write that function right over here. For example, here the ETH amount becomes the dollar amount, and then we would calculate the ETH amount using that price conversion, and then we will return the ETH amount. So we can write a separate function as well, meaning that we copy and paste the function that we wrote on the price conversion, like this one, which uses the aggregator.sol, which uses this aggregator, which is a simulation of aggregator v3 interface. Later, when we migrate to mainnet or testnet, we will change this and directly use the Chainlink aggregator v3 interface, but this one is a simulation. So as you can see, it's mock price fit, not the actual one. And anyway, we'll write this function in our own contract and use that in order for the price conversion to happen, and this makes our contract much more clear. So whenever we want to get the price, we can get the price in dollar rather than Ethereum, right? So the price here, the get current price here, will show us the price in dollar rather than Ethereum, right? And then in this function, it will calculate the price in Ethereum, and we can consider that as a variable that we can also show in our contract and see what the price is. Anyway, let's get us started here, and instead of showing you how things could change, let's write it together and see how we can make this smart contract work. So the first step is to create a new file here. I can call this bonding curve for dollar .so. So this is just a name, but you usually do not name it like this. It's just bonding curve smart contract. But in order to specify it and sort it out, be able to differentiate it from the other smart contracts that we have previously had, I'm naming it this way. Anyway, let's copy and paste the first two lines. Actually, let's copy and paste the whole contract related to bonding curve integral.so. So Control A, Control C, and paste it in here. Anyway, what we're going to change here is we can add a function, or in order to make this contract with less gas fee, we can just put in right here. But for more clean coding and for a better understanding of the contract, I'm just writing another function. But notice that it's better to write less number of functions to pay less gas fees when interacting with the contract. Anyway, so I'm going to write a function called price conversion. And notice that the price conversion here that we're going to have is the opposite of what we have in this price conversion.so, because here we would convert VAY to dollar, but in this new contract we want to convert dollar to VAY. So it will be something just opposite to what we had in here. So the multiplication becomes division, and division becomes multiplication. Anyway, and the amount will be in dollar instead of VAY. So the resulting value will be amount in VAY. Anyway, it's just a simple mathematics and nothing more. So let's get back to where we were. Bonding curve in dollar. Let me close this one so that we don't get confused. Okay, so price conversion, and it's better to name it dollar to VAY. Dollar to VAY. So it's just the same as here what we had in price conversion. So we'll get the UINs to 56 instead of in VAY, we'll get in dollar, and we'll return all this stuff here. We just need to rename them and change the formula. Okay, and here we go. So first of all, let me have a little bit of change here. So amount in VAY, amount in dollar becomes amount in dollar. So public view returns you into 56, and you get the latest round data. So the price that enters here is the same, will be the same. So we won't change the aggregator.so because it gives us Ethereum pair with USD, right? So we won't change this. Instead, we change the formula. So here it was amount in dollar, so it becomes amount in VA, and this one becomes amount in dollar. So now the division, the multiplication becomes division, and division becomes multiplication, right? But with the difference that this one will be cut and pasted over here, right? So the dollar amount will be multiplied by 10 to the power 18, because each VA is 10 to the power 18 Ethereum, right? And then we'll just divide it by the ETH price that we get from the latest round data of the aggregator.sol, which in the future becomes the Chainlink aggregator v3 interface. Anyway, once we calculate the amount in VA, we'll return it, right? Instead of returning a dollar, it will calculate it in VA, and this actually becomes the ETH amount, right? So the ETH amount in VA. So first of all, let me tell you that this ETH amount here becomes the dollar amount, and then we will have the uint 256 ETH amount, which will be equal to this function here. So we'll use this function $2 so $2, and what we'll input here is the dollar amount, right? So here we go. So we'll use this function and it will return the ETH amount like this in VA. So this get current price will return us the dollar value here instead of the Ethereum value. So get current price, we can change the name from get current price to get current price in dollar, so that you know what you're exactly seeing, what kind of price you're seeing. So once it changes, whatever the formula that we have will be the price relative to dollar, right? So the price in dollar, and the price of each token, for example, follows this formula relative to dollar. Anyway, let's save the contract, see if we have any more errors. There seems to be one in here. So price feed. Okay, we should also import the aggregator.sol just the way we had in price conversion. So import, let's copy and paste it right over here. Let's save this, and let's see what more problems that we have. Okay, there seems to be persisting price feed that latest round data. So let me check the price conversion here. Okay, we should also give the actually have this constructor for the price feed, right? So we should also add this to our constructor of the price, and also define the aggregator interface price, public price feed. So copy and paste it here. So we've got the price feed, and I guess we need to also include, although it's showing okay, but I think we need to also put it in the constructor, right? So here is one of our constructors. So let us do this without ever needing to enter the deploy contract, but no, actually we need to do this to do so. So I will do this for you. So notice that here you need to add another variable. So the variable we had here was address price feed. So I'm gonna add this inside this constructor. Notice that you cannot write another constructor because you only need to have one constructor, right? So instead of it, we can add the price feed. So let me copy and paste it over here, and here we go. So let's save this, and as you can see, it's successfully compiled. And okay, that's it for writing this contract and compiling it. In the next video, we're going to test it and deploy it and see how it works. So until the next one, goodbye.